All right, guys. So the concept that we are going to have a look at today is called discretization. Okay. In order to understand what discretization is, we will have to start from understanding what continuous and discrete data are. So basic concept, but let's just start with a small refresher so that we are all on the same page. Okay. So what is a continuous variable when it comes to, let's say in statistics? A continuous variable is something that can theoretically take up infinite number of values in a given range. Talking about something like age, maybe. Okay. So age is a number that can start from 1 and go all the way to infinity, theoretically. Yes, I do understand that there are practical limitations to a human life expectancy, right? It could be, I don't know, 150 or something. Okay. I'm not sure how old was the oldest human in the history, but let's just assume it. Okay. Someone might even have gone up at 200. But theoretically speaking, we can still go forward, right? Theoretically. So that is why I call age to be a continuous variable, because it can take up any number of values in the particular range. Okay. And another example could be maybe something like income, right? It could also be in negative, right? It could mean that you are in debt essentially. And it could also be, relatively speaking or theoretically speaking, it could be in billions or trillions. Okay. Think about the richest people in the world. So these variables that are age and income, since they can take up any value in a particular given range, right? We can call them to be continuous. If that is the case, what are discrete variables? These are variables which can take up only a finite set of values. Okay. If I am talking about, let's say, this might be a weird example, but try to relate with me. Okay. Let's say I have a chemical in my hand. Okay. Let's say if I have it is some sort of a some sort of a face product or facial cream, let's say, and I'm trying to assess the toxicity of it. Okay. If I have the list of all the ingredients that goes into this particular face wash or something, face wash or face cream, I can figure out what is the toxicity. Okay. And I might be labeling that toxicity as something like low, okay, or it might be something that is neutral, okay, or it might be something that is uh, I don't know, highly toxic. Okay. So since the values that my toxicity can take up, the toxicity variable can take up are low, neutral, and high. If you're looking at, let's say, pH, that again is something like basic, it could be something like neutral, or it could be something like acidic, right? Although, yes, there are continuous numbers associated with pH as well, right? It starts from 0 and goes all the way to 14, right? And we have the categorical counterpart as well, right? That is basic, neutral, and acidic. So I hope you, at this point of time, at least understand the difference between a continuous and a discrete variable, right? The discrete variables over here can take up only a set of finite values. Okay. On the other hand, your continuous variable can, theoretically speaking, can take up any value, okay? Infinite number of values. So with this concept solidified in our brains, let's try to understand what is discretization. Okay. It's a complex word, discretization. So what this basically means is we are trying to convert a continuous variable, right, into a discrete variable. We are discretizing the continuous variable, right? So first, let's have a look at how we can do this, how we can convert a particular continuous variable into a discrete variable. And then I will talk about why we do this and how it is helpful and everything. Okay. So these are few of the methods that can let you do discretization. Mind that this is not an exhaustive list. There are many more different philosophies and many more different techniques associated with discretization, but these are the few uh, that we will be discussing in this video. Okay. Talking about something called as equal width bin, right? So this, as the name suggests, is going to create bins of equal width. Okay. You at this point of time might not be able to understand what bins are or what I mean by bins. Let's say I have the age feature over here, which goes on like starts from somewhere around 20. I have a 22, a 28, okay, a 30 over here, a 40, a 45, a 50 over here, a 55, and so on. Okay. So what I can do in this particular case is I can create bins of equal interval. You can say something like 20 to 30 years of age is one of my bins. Okay. And let's say 31 to 40 is my other bin. Okay. And similarly, 41 to 50 and 51 all the way to 60. Okay. So what we have done over here is we have created 4 bins, right? So all of this value, for example, this particular value is going to go into the bin 1, right? This again to the bin 1 again, right? And finally, again bin 1. And the 40 over here, okay, this over here should have been 40, for example. So this would go here, 45 would go here, 50 would go here as well, 55 would come here, right? And 60 over here would come here. Okay. So just yes, right. So what I've done over here is I actually have converted all of my continuous numbers over here, all of the items in my continuous variable age into a certain categories, right? I have created 4 categories over here, and I'm able to classify each of the items into one of the category. Hence, discretization is achieved. Okay. This is one of the methods to do this. What is the important thing to notice over here? The bins that we have created is equal in size. Okay. So the second method that we can use to do discretization is called equal frequency binning. You might notice over here the problem with equal width binning is that you might have certain bins over here that have high number of items, and you might have certain bins which do not have any items whatsoever, right? So what equal frequency binning does over here is it is going to start by creating a bin, okay? And then what we're going to do is keep adding elements into the bin, right? First, we'll have to order them in a particular ascending or descending order. Let's say ascending order, which I believe it already is, right? It is already is in ascending order. So we will keep adding the items one by one into the bin. Okay. So let's say I have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 items over here. Okay. And what I want to do is create maybe 3 bins. Okay. I can specify how many categories I want to create and everything. So if I want to create 3 bins, that basically means that there should be 3 items in each of the bins. Okay. So that is what equal frequency binning is all about. In the resulting bins, all of the bins are going to have same number of items, right? So to achieve this, let's say the first 3 values at 20, 22, 28 are going to come into this bin, right? 20, 22, 28. And in the next bin, we would have the next 3 values, that is 30, 40, and 45, right? 30, 40, and 45. And finally, in the third bin, we are going to have something that is 50, 55, and 60. Okay? 50, 55, and 60. So the good thing over here is that we can see that all the bins are having the same number of values, right? Same number of items. Okay. So it is a good representation of the continuous feature that we had in hand. The problem over here is the only thing that the width of the bins are not going to be consistent or uniform. Over here it's somewhere 30 to 45, and over here it is 50 to 60, right? So the bin size over here is 8, over here it's 15, and over here it is about 10. This is what equal frequency binning is. Okay. What do you mean by clustering based binning is you have certain machine learning algorithms like k-means clustering, right? Which essentially does what? It is going to look at a particular data point and it is going to tell me which cluster it belongs to, right? So that also in a way is assigning a particular bin or assigning a particular cluster to the data point, right? So this can also be used for the binning purpose or discretization purpose. And finally, we also have something that is custom binning, right? This comes into the picture when you want to create bins of custom frequency or custom interval size, right? Because let's say you have a good domain knowledge around that particular field, and you want to create the bins accordingly, right? For example, if I have a customer base of people of different age, okay, I would have people from the age of, I don't know, 18, 19, 20, 21 or something. Okay. And then I have people from 22 all the way to somewhere around 40s or something. Okay. And then I have older people, right? 50s, 60s, and those kind of things. Right. So if I'm creating a product which is uh, perceived very differently by different age groups, I would want to create those bins accordingly, right? So these set of people in today's age might be, I don't know, Gen Z. We might call them Gen Z, right? And even this people over here, I believe, right? And we have people in their late 30s and late 20s who come into millennials and everything, right? And then we have people like boomers, right? So we have all this categories, right? So over here, the range of the bin, the item, the number of items in the bin and everything is going to be very custom, right? Very custom to our use case. So that is also one of the ways that you can create these bins. So I hope it is clear as to how you are going to create the bins over here. So the next question is, why do this at all? Okay, why create these bins? How are they helping us? Okay. So the first thing first, when to use this, I'll talk about these two visualizations in just a minute. Okay. When to use discretization is, first of all, you have certain algorithms which are going to benefit by using categorical data rather than continuous data. Example being a decision tree. Okay. When a decision tree comes across a continuous variable, let's say age over here is a continuous variable, like when it comes and sees that continuous variable, it is going to create a lot of splits. Okay. It is going to create a lot of narrow splits. It is going to check on every possible value of that continuous variable to see on which split is it gaining most information. Okay. Now that process becomes a lot easier for the decision tree if the variable is categorical in nature, right? So to prevent the issue of creating those multiple splits and later on overfitting onto the data and everything, you can discretize your continuous variable and then feed it to a decision tree, right? That is one thing. It improves your model interpretability in ways, right? By creating categories over here, it is going to improve the interpretability. I'm going to talk about that a little more using this visualization, right? So I'll talk about that. And also when it comes to, let's say, handling outliers as well. Okay. So if you have the age variable again, I'm using that again and again because it's a just a good example to help you understand the concept, right? So if you have 20, okay, 22, 24, a 40, a good 50, okay, and finally, let's say somewhere you have this particular age as well, which is a huge outlier, right? So this could be a monk from Himalayas who's coming down to buy something from you, but in any case, this is an outlier, right? But when you bin or when you discretize your particular continuous variable over here, let's say these people are going to come into the young group maybe or minor or whatever. Okay, these people might be adults, right? And this thing over here, anything 60 and above, let's say 60, let's say there's 60 over here as well. All of these people are by default going to get into the category of senior citizens, right? So it does not really matter if there is a 150-year-old outlier over there, right? When you create categories out of a continuous variable, the issue of outlier is also taken care of, right? So these are the few benefits and these are the situations about when you can use discretization. Okay, so let's look at a situation how discretization is helping you. So over here, I am plotting the age. It's not really visible over here. Let me make that visible. Right, so you're plotting the age against risk of default. Imagine that I am running a bank, okay, and I have made some sort of a, a algorithm or whatever that is going to quantize or quantify your risk of defaulting on a loan, right? If you take a loan from me, how risky is it for me to give you that loan? Right? So you might be, in actuality as well, you might observe this kind of a trend that is when it comes to younger people, let's say in 20 to 30 years of range, this might be people who are more likely to default on a loan because these people are likely to not have a stable income or their spending habits might be out of control, whatever might be the reason, but these people are likely to be at a higher risk level. Okay? And as you progress down your career and you get older, uh, some sort of a stability kicks into your life, right? Uh, the money that is coming into your bank account would be in a stable, manner, and you would be able to repay your loan in better manner. And similarly, when you get older and older, right? So your income source might stop, okay, and you might have other liabilities to take care of. Those kind of things would increase, and your risk of defaulting on a loan would again, shoot up, right? So this relation between the age and the risk of default in this particular case is quite non-linear, right? So this is not really giving us a lot of information in terms of how risk of default and age is being related over here. But when I bin it like this, right? When I create a bin of 20 to 30 years old, 30 to 40 years old, 40 to 50, and 50 to 60, I created 4 bins over here. Now things are much more clear in terms, for example, I can say that people who are in the range of 20 to 30, their risk of default varies from about 0.8 all the way to 1.2, right? So you are able to see how each of the bins are acting independently, right? This is one of the benefits of binning. Okay. Finally, let me just show you one instance of how categorizing your data is helping your decision tree algorithm as well. You need not look into the whole code right now, but let me just explain what it is, right? So again, the same example, I have the age and the risk of default as my variables, right? So if I'm trying to predict the risk of default using my age, right? I have created 2 versions over here. One version uses the continuous age as the input or independent variable, and the other one is going to use the discretized, uh, you know, or categorized variable as the input. Okay. And what I did over here is again just fit both the models And if you compare the results of both of these models, you would be able to see a good improvement in the error that is made in the discretized data. Okay? Although the error in this particular case might not be huge, right? You would come across other situations where discretizing is really helping your machine learning performance. So this was it about discretization. I hope the concept is much more clearer to you right now. Moving forward, we will be looking at these kind of concepts a lot more. Okay? So up until then, signing off.